I have used this arrangement for sideband noise measurement in 2 previous videos, and the impression you can get from those videos is that this is easy, but that's not true. This is very complicated, and the reason is contact problems. I am using cables, double screen cables with BNC connectors, and if any of these connectors has a poor connection on the ground, there is interference. I have shown such things on a few occasions, but how often it happens and how difficult it is to manage I have not shown previously. This video is about hunting such problems. At the moment, the problems are there, but not very large. You can see these structures and also these carriers. They don't come from the oscillators I have, they come from the outside, and they're picked up somewhere, and I don't know where. And often it is much worse than this. And I move the connectors and replace cables, and suddenly it looks good for a while. And I want to do this more systematic, and I'm now trying to document what I will do. And I don't yet know exactly what I'm going to do, so you will see my mistakes as well as what might be successful. The master ground point is here. This red cable here is a very thick cable. I think it's 6 square millimeters or something. And it goes from the computer chassis, and it helps for 50 Hertz interference on the sound card. And here is a connection to the cable that comes from the signal generator. This one that injects this one, which is not on at the moment, which would inject the test signal. And here I have a split ferrite core with a winding on it, and I put it on one of the cables coming from the power supply. It's a coax that puts power to this one, the local oscillator, and in this core I inject signal from this signal generator like that, and what I see then on the screen is this very large signal. Ideally it should be 0. So sending some voltage on that cable is picked up somewhere, and the problem is to find out how does it happen. And to that end I will use this thing. This is a high voltage cable. It is about, well, maybe 12 millimeters outer diameter, and with a very thin inner conductor. And I'm using only the outer conductor to get a low impedance cable wire to try to connect various points on the system to that master ground point, to try to understand how currents are flowing and where maybe there is a connector problem. And here it's how it looks. I have disconnected the RF parts, all this stuff, and I'm now supplying from here only 2 cables with, well, 13 volts I think it is. One into the UADC4 and the other into the triplexer. And this looks fairly good. But now when I connect this ground wire to the chassis here, you can see nothing happens. I can go on this BNC connector here, and there is a small problem. You can see a lot of 50 Hertz coming up. So I go on the ground side. And it's much better. So there is some resistance or some whatever in the T connector here. But when I connect here on the BNC connector and look, I don't see any such problem. But the important thing is going to the other end of the cable like that creates this horrible situation. A lot of interference means I have a problem with audio frequencies. I have moved the ground to the PC to the box of the UADC4, but I have inserted a choke here that doesn't affect 50 Hz or its overtones, but it does give about 15 decibels of attenuation at 10 MHz, because I have grounded things here at 10 MHz, and I want to have the master ground for 10 MHz here, where I had grounding before. Now I have dummy loads as input, and I don't connect this cable anywhere. Then the screen looks like this. Very nice, I don't see many spurs, very weak. The noise floor here is at minus 142.6, and the correlation spectrum is 18.5 dB below that. 20 kilohertz away from the center, the sound card is better, and there I can read the noise floor as 143. Minus 143 dB, and the correlation between the two channels is 21.5 dB below that. Now I have connected the mixers, and I have this local oscillator running, and the ground of one of the BNC connectors on the directional coupler is connected to the master ground point here, as it will be later when the cable goes through there from the spectrum analyzer. What I see on the screen is not really as nice as I would like it to be. There is a lot of noise at the center, although it's not so bad here. But it's not at all as good as before. Anyway, the problem is audio, so I put the low impedance ground between the mixers and the triplexer, and then it's obvious that there is an improvement here at the center, and probably a very small improvement here, but when I look at the correlation spectrum, I see a significant improvement. This is now 570, 600 averages, 14 decibels. And I remove this copper and clear the correlation. Suddenly, this is what I see. I'm not aware of having changed anything. Although I had a crash of the program, I tried to run the spur removal and that caused a crash. And it's now running with the dummy loads here. So I will reboot and see if something went wrong with the sound card. Or rather with the drive routine for it. Unfortunately, the UADC4 has crashed. It seems the firmware of the board doing the USB communication has failed. That's because I had a bug that caused Linrad to crash under Windows 7. Now I'm running a Delta 44. I have a correlation at 11.8, and the noise floor at minus 142.6. And I switch on the test signal here, which should be at minus 50, which it is. So it is now calibrated again. Now on the other side, correlation is 7 dB and the noise floor is 142.0. Once more, 142. So it is not quite as good here, because here there is no notch. This notch I have at minus 50 kilohertz. I have switched off the oscillator, and so this is just the direct conversion test receiver. And as you can see, the noise floor did not change much. The UADC4 is a better sound card, and particularly I don't have all these interference problems with it. But I can see here correlation is larger. It's now 12, and with a noise floor at 142.7. So what I have seen is essentially the noise from the Schottky mixers, probably. I mean, it is a sideband noise because it comes when I switch on the oscillator, and it can't be on the frequency because of the notch filter. So it should be the Schottky mixers. Or it could of course be something else, poor connection somewhere, or maybe this hybrid has something in it that isn't really what it should be. I don't know. I will try to clean this up a little bit, because when I disconnect here the break-in box of the Delta 44, oops, like that, then things are much better. So I need a better connection. I have removed the Delta 44 breakout box and connected coax cables to the appropriate pins on the 15-pin D-sub. And I have added here a common mode choke, 3 turns, that attenuates significantly low frequencies and also high frequencies. It's not normal iron, it is this thing, Vacuperm 100, with a permeability of 71,000 approximately. I can demonstrate what this thing is doing by adding a shorted turn here. This is what I'm seeing now, and I short circuit, and you can see interference goes up a bit. And now I removed. Before I had all these other arrangements, this effect of this thing was bigger, but I have done what I have been able to bring down the low frequency noise from the system. And I'm again feeding 2 signals into this direct conversion receiver I use for measurement. One is at minus 49.6 and the other one is at plus 0.34. Means they differ by almost exactly 50 decibels. And here is that signal, 50 decibels down, and I calibrate it to show minus 50 on the S-meter graph. The noise floor here is minus 143.37. And I can clearly see that the correlation spectra is much lower. Actually 12 dB. And if I wait, maybe even a little bit better. So the correlation spectrum is 10.8 decibels below. That's with 4,600 averages. It won't go further now. There is a serious error in the measurements I have presented so far. This is the signal, and it is at minus 50, but the mirror image here is only suppressed by 5 dB. That's odd. And the reason is that the mixers are saturated. So we are far outside linear range and things are not reliable here. I have inserted 6 decibels of attenuation here, and rather than going down by 6 dB, the reference signal has gone up by 3 dB or so. So things are not what I have been thinking. So now levels are lower. The strong signal is at minus 5.31 or so, and the weak one is at minus 55.3 or so. The test signal here is now minus 50, and I go for the mirror, it's here, and it's suppressed by 17 dB or something, 50 to, yeah. So it is a reasonably linear now. And let's see where the noise floor is. This looks much better than before. I had calibrated for minus 50, and now the noise floor I see is minus 143.7 with correlation 12. So this is what I find for the mixer noise, and it's quite clear. It looks much better than before. Correlation, the green curve is significantly below the yellow on this side where the notch is, and here it's very different. The noise level is much higher. So here I see the noise from the less good oscillator, this one, while the what I call a local oscillator, this one is better. And what I see here is minus, well, these are the numbers I measure, and that turns out to be minus 185.7 dBc per hertz. If that is the mixers or this local oscillator or something else, that I don't know. So next step will be to try to make better mixers. because running higher powers in the mixers without getting them non-linear should make this situation easier to understand. I will now switch off the oscillator like that, Alt Z, and see where is the system noise floor. And it turns out to be minus 143.7 and correlation 12. That's exactly the same as I had with the signal present, which means I don't see any sideband noise. I was just looking at the noise floor of this test system at minus 185.7 dBc per hertz. So, better mixers, that is what I need now. Even with the oscillator off, I see a clear asymmetry between the two sides, here and here. That's because of different impedances into the receiver, the direct conversion receiver with these two mixers. So I can replace this filter that comes from the oscillator, a disconnect here, and put a 50 ohm dummy there, and then reset the correlation. And look. And now it is perfectly symmetrical. So I didn't see the noise from 50 ohms here. The noise was lower because the filter impedance is very low at the notch.